Hello everybody and welcome to GC Safety Demo. My name is Nicole Nichols, or Nikki Nichols, in case you don't know who I am. I am the quality control technician here at Siegfried at the Penfield site. In my past experience, I was a raw materials chemist, so don't you worry. You guys are in good hands. I know what I'm doing, I think. Anyway, welcome. And then first things first, we're gonna go through here. My little mini me, isn't that cute? All right, so what topics are we going to go over today? We're going to go over chemical reactions, we're going to go over spills, and we're going to go over eye wash stations. So these are things that affect everybody throughout the site, whether you're in the lab, you're out in production. These are all things you can encounter not only here on a day-to-day basis, but even at home and while you're away. First up is chemical reactions. The one you guys are all here for, right? All right, so who can name me a couple chemical reactions or real-life examples of a chemical reaction? Do we have any volunteers of information? Anybody have any ideas? A real-life example of a chemical reaction? No volunteers?
Caustic plus acid, sulfuric acid giving a sodium sulfate.
That's a good one. All right, so I have some examples of everyday chemical reactions that we see. So this includes rusting of iron. So that is going to be a redox reaction. Cooking of food, decomposition. We have respiration. You're breathing in and of itself is a chemical reaction. That oxygen exchange that happens in your lungs when you breathe, and the breaking down of that oxygen into your bloodstream. These are all chemical reactions that happen every day. We don't even think about it. Baking a cake with baking soda, the leavening agent that happens inside, that is not only decomposition but displacement. We also have vinegar and baking soda, the classic volcano experiment we all did as kids, right? And also heat generation, combustion, burning. So that burning of a candle on that birthday cake we just made with that baking soda, that's another reaction that's taking place. Now, there's a couple of other different reactions that happen. They fall into about 5 to 7 categories. We have synthesis, which would be the creation of like table salt. We have decomposition, which is our cooking again. A single replacement reaction, think of the Statue of Liberty and the patina that's on the outside of the Statue of Liberty, that kind of greenish color that it gets. A double replacement reaction, that is that vinegar and baking soda that we just talked about. Combustion being fire. We also do have additional two that could be considered. There's a precipitation reaction, which would be kind of like the development of soap scum. And then, of course, acid-base neutralization reactions. Just like if you were to take a Tums to settle an upset stomach. These are all the different types of reactions that we encounter in our everyday lives. Chemistry touches every part of our lives every day, even if we're not at work. We got to deal with it, right? And I found out recently we do a huge list of different types of reactions here. I'm going to be honest, I'm not going to be able to pronounce most of these. And if I do, I'm going to stumble over them. But there is an enormous list of things that we do here on site when we're making our medicines that are going to go out for our patients and our customers. It is amazing the amount of education, knowledge, science, chemistry, everything that we do here. And I think everybody should really take a step back and really feel some pride in everything that we do here, because it is absolutely amazing. So there's some different things to remind when we're thinking about reactions. I have 3 listed on the handout that provided you today: exothermic, endothermic, and catalyst. So exothermic are reactions that are going to emit energy, right? So they're going to be absorbed as heat. That's the type of reaction we're going to be doing later on today. If you do want to touch the phone, I would ask for you to put on gloves, just because safety first. Now, examples of these exothermic reactions would be like a campfire, right? Where again, that combustion is emitting the heat, and water to acid or base reactions, and that heat that gets generated when we're creating those solutions here in the lab. Endothermic reactions absorb the energy, then we observe that as cold. So an example in the laboratory that I can cite is mixing acetonitrile with water. You mix those together, the bottle becomes very cold, even if both of those reagents are at room temperature, because it's absorbing the energy around them. Another example of that would be dissolving salt with water. Large amount of salt and water will make it very cold. So today we're going to be doing a catalyst reaction. Now, the reason why I selected this particular type of reaction, because we do catalyst reactions here. So this is a good visualization of what happens in the reactors. Is this exactly what happens? Probably not. We're probably not creating water and oxygen, but that's what we're going to be doing today here. So, I gave you guys a little bit of a preview of our equation here. Who can balance the equation? It's an easy one. Go ahead.
Yeah, so the two of the peroxide hydrogen, so then we need like two of the hydrogen, one of the oxygen.
That's easy, right? Yes, he is. All right, well done. This is a very simple stoichiometric equation for us to balance out here. So for every 2 of the hydrogen peroxide that we have, we're going to generate 2 water, and we're going to be off-gassing that oxygen. And this is how we're going to be doing it. So I have warm water here, some city water, we have hydrogen peroxide, and we have some Dawn dish soap. So before we get going with any experiment, it's important that you have the safety data sheets on hand. Yes, I have a safety data sheet for water because water is a chemical. So it's important that you know what type of PPE you need to do these experiments. This particular experiment, I need my safety glasses. I'm going to be wearing gloves, although this is safe enough for me to do without gloves. We're going to do everything as safe as possible. I also have safety data sheets for the dish detergent, hydrogen peroxide, and yeast. So when we're going to go through with this experiment, it's going to be fun. But I want you guys to understand what's going to be happening. So this is a reaction where we're going to be using the yeast, or you could use potassium iodide, as the catalyst to the hydrogen peroxide. And what's going to happen is when we add this catalyst to the mixture that we're about to make, it's going to release oxygen as gas. Now, how we capture that is using the Dawn dish soap. So that's going to be the visualization of the oxygen escaping out of the reaction. Now, naturally, hydrogen peroxide, if you were to have a bottle at home sitting out on your countertop for the past year, chances are it's probably water. This likes to readily break down into water and oxygen. But the catalyst that we're going to add is going to speed up that reaction, make it happen a lot faster than if this was just sitting in my pantry at home. So as I stated before, that this is going to be an exothermic reaction, so it's going to generate some heat. I'm going to start donning all my gloves and preparing the solution to go. In the meantime, do I have a volunteer to pick a color? So, no? Nobody wants to pick a color? Blue? All right, we'll be doing blue. Don't worry, we'll be doing it twice so you guys can pick a second color too. Okay, don't like the blue.
Yeah.
All right, so first things first. We're going to put on our gloves. We're going to take our little friend here. He's all smiling for you guys today. And we're going to pour. It's okay. We're going to be going over spills. That's great. That wasn't planned.
Do you have containment? Do you just want that?
No, we're fine. I got chem wipes over here on standby.
Prepared, that's excellent.
And I have a trash can over here too. All right. So we have our hydrogen peroxide. We're going to add our dish soap.
Nikki, can I change the color to green?
You can change the color to green. We didn't add the color yet.
That's okay.
And we're going to put a good amount of dish soap and give this a nice swirl. So we
What's
get
nice
all that
color?
dish soap.
That real right.
All right, so you want green?
Yes.
All right, we're going to be doing a green. Green's my favorite color. I don't know if you knew that.
I
Yeah.
didn't know that.
We're going to make sure she's nice and pigmented. We want this to be fun, right?
Did not great.
All right, so we're going to have green there.
That's nice.
So that's all ready to go. We'll give us another swirl so we can distribute that color a bit more.
Look at that.
There we go. All right, so over here I do have some warm city water. So this actually feels good. I do have additional city water over here in case I got too hot. All right, so I'm gonna add yeast to my test tube. Come on, it's all nice and staticky. I didn't want to open it ahead of time in case. Alright, so I'm going to swirl this around to wake up the yeast because we want them working for us. This is the fun part. You get to sit here and mix yeast. This is everyone's favorite part, right? Alright, so who has seen this particular reaction before? Who's familiar with it? 1, 2, 3 people? All right. So you guys already know what's going to happen. This is not going to be any fun for you guys. Alright. We're gonna add a little bit more water to this, just because she's a little thick. Alright, that's the consistency. Alright, ready? Look at that. So I learned at home, when doing this at home, to put it in a large container. So if you do this at home, don't use a cookie sheet. It'll get all over your countertop. I'm speaking from experience. My daughter, though, found it very hilarious. So as you can see, that oxygen is getting captured by that soap bubbles and it's coming out. Now I will let you know, if you do use a stronger percentage of hydrogen peroxide, it's going to actually jump up a bit. So the other commercial grades you can buy yourself as a person that's not working in a laboratory is a 6%. You can buy that at Sally's Beauty Supply. I'm using a 3% hydrogen peroxide solution. So.
I think we have some 30%.
Oh, Jimmy, that's going to be crazy.
Get the ceiling out.
All right. So I'm going to do it again, but I'm going to fill it up with even more hydrogen peroxide. We're going to see what happens. What do you think is going to happen if I add more hydrogen peroxide? There will be more, right? All right. So we're going to move this guy into my bin. All right. So we did green last time. What color should we do this time?
Red.
Red?
Yeah.
All right. We're going Christmas on this. All right. Let's go. All right, so we're going to do another round. We're going to fill the second container with even more hydrogen peroxide, and this time,
Do you have some 30%?
if we do, we're going to hit the ceiling if we do
Snap.
30%. All right, so we're going to fill her up even more. So I think I filled the last one up about 200 ml.
I was telling her she should do Pepsi and Mentos.
Oh, I got 2 whole bottles. We're going to have some
Have you
fun.
seen that?
And we said red, right?
Yeah.
All right. Fill it up with our soap
How do you know how much dish liquid to put in there?
until the ancestors say stop.
Oh, snap. Okay. I'll listen out.
All right, we're doing red. All right, so we have our next one. We're going to give this a swirl. If she behaves, if not, I have an unused stir bar we can use. All right, probably going to end up a little bit more on the pink side.
Oh, yeah, that's super good.
Add a little bit more red. All right. So we're going to do the same thing again, but we're going to do the same reaction, but with way more hydrogen peroxide. We're going to see what happens. I don't know. I don't know.
Same amount of yeast, basically, too.
Same amount of yeast.
Okay.
The only variable we're changing is the amount of hydrogen peroxide. And I'm approximating the amount of
Dish soap.
dish soap.
Okay.
Thank you. I couldn't think of the word. So the only variable we really changed is the amount of hydrogen peroxide. We're going to see what happens this time. Gotta wait for the yeast to bloom. So when it starts becoming like a uniform kind of like mucky color, like silt, is kind of when I start going, because we want to make sure all that yeast is warmed up and ready to go. You also want to make sure you don't use too much hot water. Make sure that it's about 100 degrees to 110 degrees. You don't want to kill the yeast, but we want them active and working. So here we go. See how that is a nice uniform kind of beige? There we go. Next one. Ooh. It didn't even wait. All right. So again, we're going to create this one. It actually ended up being more of a pinky color. All right, very cool. Good color selection. All right, so the important thing whenever you do a reaction, especially one like this where you know it can be messy, is always know how to clean it up. Luckily for us, this is something safe enough that it can just go down the drain. The byproducts of it are oxygen gas that is captured into the soap bubbles, and then water, and then of course a little bit of food dye. So this is something that is very safe for you to go down your personal drains at home. It's not going to affect anything. It's extremely soapy water. And then I had a little gif of the reaction going. I didn't want to spoil it for anyone who didn't see it. So the next thing we're going to talk about is spills. So give me a second to tidy up. And then the reaction up here is still kind of going too. It hasn't stopped yet. So this is going to ooze for a bit while we're going. Again, if you do use a stronger hydrogen peroxide, it's going to be a much stronger reaction. There is a kids television show where I got this idea from called Emily's Wonderland. And they do a version of this experiment with the very strong hydrogen peroxide, and it jumps up. It's actually pretty cool. Do recommend it if you want like a good science show. It's on Netflix. All right. We're gonna put my warm water back on there. All right. So, luckily for us, I did make a bit of a mess. So we can clean up my mess. So it's important, like I said before you do an experiment, is to make sure you have your safety data sheets on hand. Now, here on site, do you guys know where to get your safety data sheets from? Yep, they're on the internet. And here in the lab, we also have them printed out in binders in the hallway as well. That's mandatory for our reagent SOP. We need to have them on hand. So I did print out the SDSs. All my SDSs here tell me everything I need to know. So the section of the SDS that's important is, in case of injury, you need to know your first aid measures. That's going to be section 4 of your SDS. Firefighting measures, that's more for emergency response if there is a large spill, for them to know what's going on. That would be section 5. Accidental release measures, that is if it gets into our environment, what are we supposed to do about it? But the section that most chemists tend to look at is section 7 and section 8. So section 7 is handling the storage. How am I supposed to safely store the chemical? How am I supposed to handle it? Section 8, exposure controls and personal protection. So it's always important that you know what you're working with. If you don't know what you're working with, make sure that you ask or you find out. A quick anecdote in regards to that. When I was a new chemist, I on the bench probably a little over a year. I was doing somewhat chemistry in the hood, wearing gloves, goggles, sash down, doing everything I was supposed to. I spilled a little bit of a chemical on my hand. So I went I cleaned up the hood and you know, left the paper towels in the hood to air out so this way the volatile chemical could go away, and my hand started burning. The chemical was chloroform. My gloves were nitrile. Nitrile gloves are not good for chloroform. In fact, I had breakthrough that happened. So I ended up going to the senior chemist that was there at the time. She had me deglove and then proceeded with first aid care on my hands, rinsing it under cold water to try to flush the skin and get it clean. It is important, 1, you know what you're working with, but 2, that you're wearing the appropriate PPE for the job at hand. If you're unsure, you don't know, or it doesn't seem right, ask questions, elevate it to your supervisor, to EHS. We will make sure you're wearing the appropriate PPE for the task at hand. That is very important. The gloves I should have been wearing were called silver shield gloves. They're very thick gloves and they're made to withstand breakthrough for chloroform and some other very nasty chemicals. So keep that in mind when you're going forward.
Do you know what they're made of? Silver shield?
No, I do not. Do you?
No, I'm asking because we just were in a really highly competitive Jeopardy game
Oh.
in the cafeteria, and that was one of the questions.
Well, we have a package in the lab for our waste disposal, so
Alright.
I can always look at that and get a
I'll
leg
look it
up
up,
there.
but okay.
So.
I don't know. I'm not thinking that's asking for that.
Please, the PE, polyethylene.
Polyethylene? Okay.
So when we're talking about chemical spills, it's important that not only do we clean it up, if it's small enough, right, safe enough to do so, but we know what kind of kit to use. And there's a lot of different components to all these kits. So first off, I'm going to clean up my mess over here, which is the water, a little bit of hydrogen peroxide and yeast. So I'm going to brush that up and clean it up. This is something I can easily clean up with a paper towel, and then the spillage that happens here, I know is safe enough to go down the drain and it's not going to hurt anything. And I'm going to put my waste where it belongs, in there. If this was a chemical spill, I would be using a chemical safety kit. So there's several different types, depending on where in the lab you are, what it is that you use. So this is the general one we have in all the labs here. We also have one additional type of kit. The additional kit that we have is a mercury spill kit. And I know out on the plant we have the big, large containment kits that have the pigs and that are snake-like and the big absorbent pads. It all depends on what the desired use is, what kind of spill kit you're gonna pick. So we're gonna go over the contents of this one. So, spill kits should come with containment bags, hazardous waste labels and zip ties, some type of inert material that's going to be able to absorb hazardous liquids, oils, any type of spill that we need to clean up that's wet. These also can, this particular item can also be used for acids and bases as well, but you always want to neutralize them first before absorbing.
What is that inert material? Is it okay for peroxide?
I'm going to try to say the name right. I'm probably going to say it wrong. Vermiculite?
Yeah.
Vermiculite.
Vermiculite, there we go. I was going to say, I'm probably going to say the name wrong. This kit also comes with acid neutralization mixture, dustpan. We also have flammable materials. So whatever my spill is, I'm going to select whichever of these bottles. So I wanted to have a little bit of each. So this kit comes with a little bit of everything. A caustic material, neutralized material, we have absorbent, we have acidic, and we have for everybody else right here. So,
What are the other jars in the kit? Just more of the
yeah,
same
they're
stuff?
more, they should be more of the same. It also comes with safety goggles, some nitrile gloves. I believe it has more of all the different materials in here. Yes, these are all additional bottles of the same stuff. So some spill kits come with diatomaceous earth. That can be used for cleaning up liquid spills, but more so like oil and grease. It helps absorb those. Vermiculite is good for multiple materials. We're talking hazardous chemicals, like acids, bases, solvents, oils, aggressive liquids on contact. It's important if you do have an acid or base spill, you neutralize it first before absorbing it with the absorbent material, and you can do that by using litmus paper. We do have some in the lab, so we would test it and see where it comes on the pH scale, and then we would add the corresponding reagent to neutralize it, and then we will clean it up with this particular material, and then dust it up, put it into the dustpan, and then put it in the bag, label it, and then that's how we would wrap it up for safety to put it in our lab pack cabinet. Just making sure I got all my things. After we clean up any type of spill or mess, it's important we also take care of the area itself, decontaminate it, and decontaminate ourselves. So check ourselves, make sure we didn't get anything on us. Make sure if we did get anything else, we take the appropriate safety precautions. And if it was a spill that is large enough, make sure your supervisor will make sure that EHS and ERT are on hand. If there is a large chemical spill and we are outside, it is important that let ERT handle the emergency. Your job is to report and to evacuate. So in summation, if we have a spill, number one, do not panic. Do not rush, stop, think. Look around. Is it safe to enter the area? Is anyone hurt? Is there any broken glass? Report to your supervisor or manager immediately. Let them decide if the spill's small enough for us to clean up. We make sure we contain it, that it doesn't go into any drains or any sinks if it happens to be on the bench top. As you can see, I have this here. There's a sink underneath here. So I had the sink blocked before we started today. Make sure that everything's contained. If the spill is safe enough for you to clean up, make sure you've done the proper PPE, you select the correct kit, you follow the steps, and then, of course, always report any type of spill to your manager. Let them decide if an incident report needs to be happened or if we need to get other people involved to make sure the area is safe. And then, of course, if you hear the sirens go, safely, calmly evacuate, go to your closest muster point. Listen to the radio. There might be some type of instructions of where the spill has occurred for where to avoid, and always stay upwind of the air source. You don't want to have those chemicals being blown into your face. All right. So let's just say I did a chemical reaction and I stood over top of it. I was not a smart individual, and I got stuff in my eyes. I'm going to have to use an eye wash station. So I have a pop quiz. How long do you flush your eyes in an eye wash station? Do you do it for 20 minutes? Do you do it for 5 minutes? Until the burning or hurting stops? For 15 or up to 3 minutes? What is the answer?
5 minutes.
15 minutes.
15?
15 minutes. It sounds like a really long time, but it's very important that we flush our eyes for 15 minutes. These are the different types of eye wash stations we have here on site. These are the ones that I've personally seen. There might be more different kinds that I am unaware of, but it's important when you're in an area to know where your eye wash stations are. So, who knows where the eye wash stations are in this lab? Yep, there's one here, and there's one over here. Now, the eye wash stations here in lab are a little bit difficult to use if you get both eyes affected with the solvent, because it's a pull out and hold, not one where you pull an arm out and lean over. So there might be some instances when, if you need to use an eye wash station and the closest one is one of those hold and pull, you might need to have someone help you hold open your eye. The important part is to flush your eyes for that 15 minutes of time. So, you should be able to locate an eye wash station within 10 to 15 seconds of your work area. So I should be able to find one within 10 to 15 seconds, because that's the duration of time that is the less likely for there to be long-term damage to your eyes. You got to activate the station. So there's different ways. Some of them have a foot pedal, some of them have a hand pedal, some of them again have that double hand. It does lock in place, but you still need to hold with one hand that eye wash. It's important, again, we flush those eyes for 15 minutes. That's important. And you might need, again, help for someone to hold open your eyes. And if you're holding open your eyes, you're not just holding up and staring, you're rolling your eyes. In fact, I have a fun little visual for you to always remember it. Thomas the Tank Engine. He rolls his eyes all the time. So whenever you use an eye wash station, be like Thomas and roll your eyes constantly. Don't worry, I won't tell your mom. All right. So, do we have any questions? All right, guys. So we went over a fun chemical experiment. I talked about different types of reactions, spills. We went over the contents of a spill safety kit. Again, it's important you select the proper item. And again, if you don't know what it is, if it's an unknown substance, that's why we tell management. That's why we get ERT involved. They're going to help and make sure that we do everything as safe as possible. And I hope you guys enjoy the rest of your
Nikki, I
safety
do
day.
have a question.
Of course.
So is the eye wash only for QC? Because I don't have access to get in here if anything was to get into my eye to rinse my eye out. Is there any other stations other than in QC?
I'm not sure. I think that we do have several eye wash stations here in QC.
I don't see anyone.
No, but we could definitely get a portable one. That is something I did forget to mention. If you do have a portable eye wash station, I have one in the vault and in the retain room. You use the entirety of that bottle and then proceed to an eye wash station for that 15-minute flush. That is just to get your eyes clear enough so you can get to the nearest eye wash station. So we could always get a portable eye wash station for you guys to have in the QA office.
Okay.
That is definitely something we can look into.
Okay.
All right, any other questions? All right, well, I hope you guys all have a great day. I'm gonna have so much fun cleaning this up for you guys.
Thanks,
You're
Nikki.
welcome.
Yeah.
Go enjoy some lunch. I don't know what we're having, but I hope it's delicious.
I think it's at 12, right?
Yes.